Hello students, welcome to Engineers Academy. Do hit the subscribe button if you are here for the first time. Now let's solve this problem from Hibbeler Dynamics chapter 16. The problem says that knowing that angular velocity of link AB is 4 radian per second. So the angular velocity of this link AB is 4 radian per second in the counterclockwise direction. It is said that determine the velocity of the collar HC. So we have to find the velocity of this collar and the angular velocity of this link CB at the instant shown. Link CB is horizontal, so this link CB is horizontal. So now if this link AB is having an angular velocity in the counterclockwise direction, so this point B will revolve about that point A in a circular path of radius equal to this length of link AB. So this point B will move up, and as a result, what will happen is that this point C will move downward in this direction. So let's draw the free body diagram. Let's say this is link AB. So this red line represents link AB. So as we can see that this point A is stationary, so the velocity of B is only due to the angular velocity of this link AB, and that velocity will be perpendicular to this link since this point B is revolving about that point A in a circular path. So velocity of point B will always be tangent to that circular path, or we can say that the velocity of B will be making 90-degree with link AB. So this is that velocity of B. This is making 90-degree, and it is given here that link AB is making 60-degree. So we need to represent that 60-degree angle here. So if this is 60, and if we draw a horizontal line here, then this angle is 60. So if this is 90 and this is 60, then this is 30. So this means that VB is making angle 30 with the horizontal. And we can find the velocity of B by applying V equals to R omega. So we can say that this will be equal to the length of this link AB, which is 500. So we can say this is 500 times the omega of link AB. So omega is given for link AB, which is 4 radian per second. So this will be basically 500 into 4. So this is 2000 mm per second, velocity of point B. Similarly, we can draw link BC. So this will be the link BC here. This point B and point C. We will have that same VB velocity at point B. So let's duplicate this, and we will have that same velocity VB. It will have that same angle 30-degree. This is that same VB, which has a magnitude of 2000 mm per second. And similarly, the velocity of C is going to make 45-degree, right? So we will have the velocity of C here. So this will be the velocity of C, and it's going to make 45-degree angle, or we can say it is making 45-degree angle, since both of these angles are alternate angles. So we can say that this is the velocity of C. Now we are required to find the angular velocity of link BC. So now if we see that initially the mechanism is like this. So after some time t, this point B will move up and this point C will move downward. So we will have link BC in this orientation. Like after some time t, we will have the orientation like this. So as we can see that this link BC, this point B is moving up, this point C moving downwards. So overall link BC is having angular velocity in the counterclockwise direction. So we will say that link BC is having angular velocity in the counterclockwise direction, which is we are required to find this angular velocity, which is unknown. We can say that velocity of C is equal to the velocity of B. We are going to apply the vector equation. So the velocity of C vector plus velocity of B vector plus the velocity of C relative to B. Now the velocity of C is having two components, right? So we need to write all these three in its vector form. So we need to write VC as a vector. So VC vector is equal to, so now as we can see that this VC is making 45 degrees, so it will have one component in this direction and it will have one component in this direction. And let's say that this is our positive x and y direction. So we can say that this is, we see cos of 45 in the negative x and we see sine of 45 in the negative y. So we can write that we see cos of 45 in the negative I plus we see sine of 45 in the negative j. So this is the Cartesian vector representation of that VC. Similarly, VB, we can write VB as a Cartesian vector. So now as we can see that VB is making 30° with the horizontal, so it will have one component, the cos component will be in the negative x and the sine component will be in the positive y. So we can say, and VB magnitude is 2000. So we can write that 2000 cos of 30 is in the negative I and 2000 sine of 30 in the positive j. So this is the Cartesian vector representation of VB. And now this velocity of c relative to b, this is always due to the angular velocity of link BC. So we can write that velocity of c relative to b is equal to omega bc. And as we can see that if the omega bc is in the counterclockwise direction, so if we curl our right hand fingers in this direction, so the thumb will point out of the screen. So out of the screen is the positive z-axis. So we can say that this omega bc is in the positive k, and cross product with the r of c relative to b. So this will be the position vector from b to c. So the position vector from b to c, this will be the position vector from b to c. So we can say that the position vector from b to c is in the negative x and its magnitude is 350. So we can say that r of c relative to b is equal to minus 350i plus 0j, since it's only acting in the horizontal direction. So the units of this will be in mm. And the units of this Vc and Vb, they will be in millimeter per second. So now putting all these in this equation, so we can say that Vc is minus Vc cos of 45 I minus Vc sine of 45j equals to Vb. So Vb is 2000 cos of 30i plus 2000 sine of 30j and plus the velocity of c relative to b. So this is the velocity of c relative to b. So we can write that omega bc k and cross product with that minus 350i plus 0j, right? So now we can say that this will be equal to minus vc, and now this is the same minus 2000 cos of 30i plus 2000, this is 2000, right? So 2000 sine of 30j, and now we need to take this cross product, so I, j and k. So now this will be minus 350 omega bc and k cross I is j, so this will be minus 350 omega bc and k cross I is j. Now comparing both sides of equation, comparing I with I and j with j, so we can say that minus Vc, if we compare the I components, so we see cos of 45 is equal to minus 2000 cos of 30, since we have this I term and this I term. So from this we can find Vc, minus will cancel out, and from this we can say that Vc is equal to 2000 cos of 30 divided by cos of 45. Vc equals to 2449 point something. So we can say this is 2450 mm per second. And similarly, if we compare the j terms, so this minus, now Vc is known, we can say that Vc is 2450 mm per second, 2450 sine of 45 equals to this plus this, right? So that is 2000 sine of 30 minus 350 omega bc. So if I bring this to this side and this term to this side, so we will have the equation like this. 350 omega BC equals to 2000 sine of 30 plus 2450 sine of 45, and dividing both sides of equation by 350 will give us omega BC. So let's do it. 2000 sine of 30 plus 2450 sine of 45 divided by 350. So omega BC is approximately 7.81 radian per second. So this is the solution of this particular problem. I hope this will help you in your learning. Let me know in the comments if this helps in your learning. Do subscribe Engineers Academy for the solution of such more problems from Hibbeler Dynamics chapter 16.